Okay, everyone. I hope you have already went to my teacher webpage and you've printed this worksheet out. Remember, go to the BAL website, go to students or staff teacher web pages, find my name, and then print this worksheet out. If you can't, well, just copy down the equation, and we're going to go over ellipses. Specifically, how to find the foci. This is where a lot of people had trouble, and we're going to need to know this because the next lesson, which is hyperbolas, these foci come up again. So this is where a lot of students are having trouble. So, notes on locating the foci. All right, the formula for the foci, I'll put it up here on the right-hand corner, is c squared is equal to a squared minus b squared. That's the formula you're going to need to find the c value. The c value is what's going to help you locate these two focal points. Plural, it's foci. Okay, so for this worksheet again, since we're going over it, it actually already has the answers here. Obviously, you can see the center's already given here, and the foci, they're already also given here. But we're going to go over it. These first two are really, really easy because the center is at 0, 0. Okay, so a squared is the larger of these two. In this case, a squared is 25. B squared is 9. Okay, so let's find that C value. Let's find that C value here. So using that formula, right? The formula is what? C squared is equal to A squared minus B squared. That's going to be 25 minus 9. A squared is 25. B squared is 9. 25 minus 9, so that's going to give you 16. It's going to give you C squared is equal to 16, but you take the square root. You take the square root of both sides, right? That's C squared. I need C. You get C equals to 4. This C, this value is the distance from the center. When the center is 0, 0, it's easy. Now remember, there's only two focal points, and they're on the major axis. The major axis is the longer part of the ellipse. It's on this longer part, right? Now again, this worksheet already has them there. They're already plotted. Okay, so from 0, 0, you had to do what? Well, if these were not here yet, from here, you'd have to go this distance from the center up, right? Up 4. And that's your first focal point, and then down 4. So that's why this point here is 0 on the x. Remember, your x coordinate didn't move. You went nothing on the x and it went up 4. And for this focal point, this other foci, the 0 coordinate stayed, and then you went, and the only coordinate that changed was the y coordinate, so 0 for the x, and then down to -4. Those are the two foci for that one. Again, when the center is 0, 0, it's easy. One more easy one, we'll go to number 2. Alright. Again, the answers are already here, but again, we're practicing. Alright, let's do this. How to get these foci. Okay, use the formula. C squared is equal to a squared minus b squared. And remember, a squared is the greater of the two. The greater of the two is your a squared. So it's going to be 36 minus 25. 36 minus 25 gives you 11. Take the square root of both sides. You get c is equal to the square root of 11. What is this c? Okay, well, remember c, if we go back to this number 1, c is the distance from the center to one focal point, and from the center to the other focal point. But you have to pay attention and see which way, or where these focal points are located. Here we had to go up and down. The major axis is stretched out on the y. See, that's why the y is greater. For this one, the major axis is, or the greater numbers on the x, so that means the focal points will be on the x-axis. Now again, this is like the key. They're already here. They're graphed for you. They're graphed for you here, but pretend those are not there, right? So you'd have to go off the center and go this much. From the center, go to the right to find the first focal point. And you had to go how much from the center this way? This distance. So for this first point, remember you're at 0, 0. But when you move left or right, it affects the x-coordinate. So the x-coordinate moved this much. It's not at 0 anymore. See, the y-coordinate didn't move. The y-coordinate is still at 0. Same thing for this one here. This is 0, 0, but I'm moving left and right, so that's going to, well, in this case you added, this case you're going to go negative root 11. That amount, that distance, and the y-coordinate didn't move. And that's how you get these. Okay, so those are easy. The center's at 0, 0. Okay, let's look at these following ones. We're going to move the center now. Okay, number 3. Let's find the c value, the c distance. Again, this one's already here. The ellipse is already graphed. We know that the foci are on the major axis. They're already plotted for us, but let's pretend they're not. C squared is equal to a squared minus b squared, where a is squared is the greater number here. It's going to be 40 minus 15. See, that always guarantees that you get a positive value here. Okay, so that's going to be c squared equals 25. Oh, good. 25 is a good number. You take the square root of both sides, you get C is equal to 5. Okay, now, here's where it gets a little tricky because the center is not 0, 0 anymore. Everything's coming off this center. The center is negative 2, 0. You got to go off of this negative 2, 0. One of these values, these coordinates, is going to stay. The other one's the one that's being affected, the one that you're going to have to add and subtract this amount, this C value, this distance amount. So which coordinate is not changing? Well, for this one here, the foci, see, the x-coordinate does not change. See, this is still the x-coordinate. Even though I'm moving up and down, it's still at x equals negative 2. So for both of these, the x-coordinate is still negative 2. It's the y-coordinate that, see, it's not at 0 anymore. When it was here, the center is 0, 0. I'm sorry, negative 2, 0. But now I had to go from negative 2 stayed, and the y-coordinate went up. How much? Well, from 0, you add 5. Well, that's why you get negative 2, 5. For this focal point, for that first foci, for this one here, again, you started at negative 2, 0. Negative 2, 0. It's still at negative 2 for the x-coordinate. But 0 for the y, see, it's not at 0 for the y. Now you're going to go down 5, or it's going to be, right, the negative 2. The x-coordinate did not change. And then you, from 0, you drop 5. Well, that's how you get those two focal points. And again, they're already here. The answers are already here. But I want you to practice and make sure you're doing this correctly. Okay, number 4. This one here. All right, let's get this C distance. Again, we know that this ellipse is a little bit more stretched out horizontally on the x, right? That makes sense. The x value is greater. So I know the focal points are here. Let's pretend you don't know that they're there, or they're already plotted here. Let's find this C distance that I have to go off of here. Again, C squared is equal to A squared minus B squared. Again, A squared is the greater number. 49 take away 4. So I'm going to give you C squared equals to 45. 45, when you take the square root of it, can be broken down into what? 9 times 5. 9 has a perfect square root. It comes out. So your the C distance is 3 root 5. All right, here's where some people struggled from here when it's something like this. Okay, this is the distance that I have to go off of the center. See, this is where some of you were thinking it's like it's always 0, 0. The center is not always 0, 0. Here you're going off of the center, which in this case for this problem the center is 0 on the x, negative 5 on the y. One of these coordinates is not going to move. Which one is it? Well, if the center is here and then this foci is this much away from it this way, and then the other one's this much, obviously we're moving left and right. It's the x-coordinate that's going to move. See, the y stays at negative 5. So for this one, the x-coordinate was 0, but I had to add this much amount.